Hello, I'm Asa from UK AI Security Institute, and this is work done with Josh and Ida as part of the Astra Fellows program. And I'm going to talk about distributed attacks, so attacks that are spread across multiple trajectories. And yeah, typically in control, we're basically assuming that an attack has to occur all in like one trajectory. The user gives the model some task, or the model is carrying out some task, and it has to like do all the bad stuff in this kind of single episode. But of course, coding agents are working on the same repo across like multiple episodes, multiple different tasks. So this is going to change the red and blue team dynamics, because the red team can like spread out their attacks. They can like set up something in a particular early PR and like exploit it later. So this helps the red team, but also perhaps the blue team gets some benefits because they have more chances to catch the red team. If they catch like, some early suspicious behavior, they can like use that to influence their like future decisions. So who wins overall? Who knows? And we built this setting to try and figure this out. It's kind of a like roughly like sort of vibe coding adjacent setting where some user is asking a coding agent to iteratively build some app or like CLI tool. So we have these like sequences of 5 PRs. They're all like adding new features to some app. And our setup is we have this like untrusted model of Sonnet 4.5 and a weaker trusted model of GPT-4.3. And we're going to consider two kind of attack strategies. One is these like gradual attacks that are distributing the attack across multiple PRs, and a kind of baseline of a non-gradual attack that executes the full side task in a single PR. And to make this a strong baseline, we like select the kind of position within the sequence that has the highest evasion rate. So this is kind of a best possible single attack strategy. We also have a bunch of different monitors. So we have some kind of standard monitors that look at purely just the diffs for each PR, and also kind of full trajectory monitors. We also introduced this kind of link tracker monitor that is also stateful. So this new monitor basically can write notes in a kind of persistent way. So it can like look at things it thought previously looked kind of suspicious but weren't good enough evidence on their own. But because it has this notepad, it can like piece together over the course of the 5 PRs what's going on, ideally. And the way it works is if the blue team catches the red team in any of these PRs, then they win. And if after the kind of 5 PR sequence, the attack has been carried out, then the red team wins. And our results were we basically destroyed the 4.0 monitor. So our evasion rates are like super high. We're like, over 80% in a lot of these cases. And the kind of basic result is that the gradual attacks were mostly better than the non-gradual attacks, these like positional attacks. Overall, the difference was like relatively small. In fact, it was just a very hard setting for the blue team. And this was the case across a bunch of different monitor types. So we had these kind of single trajectory, single PR diff monitors. And even if we have this like full diff monitor, which sees all of the diffs from each PR, they still don't do too well. But we did find that the stateful link tracker monitor does a bit better, and predictably kind of ensembling all the different monitor types does the best overall, and meaningfully like reduces the evasion rate. So ensembles are great. But this is kind of like, well, our evasion rates are all just like insanely high. Like, does this really tell us anything about the difference between gradual and non-gradual? So we kind of upgraded the monitors. We used some like really powerful monitor models. So we actually use like models like 5.3 Codex, which is probably just way stronger than the untrusted model. So this is kind of a, overpowered blue team. Though we still found there was this large gap between the gradual and non-gradual positional attacks. So the gradual attacks are still doing pretty well, even with these like super powerful monitors, and even when the powerful monitors can see all of the diffs, like the diffs across each PR. So overall, it looks like the kind of distributed attacks enable, they're like super strong, and they can beat these really powerful monitors. And yeah, come chat to Josh and Ida if you're interested in this work. And the paper should be coming soon. And maybe very quick zooming out. We have an unconference session later on like the kind of future of red teaming and making red teaming appropriate for things that are coming in the next 6 months. And maybe there are kind of similar assumptions like attacks coming in a single trajectory that we need to think about and prepare for, like models of continual learning and really powerful memory and so on. So come to our conference session later if you're interested in challenging assumptions and so on. Thanks.